Okay, now we're ready for problem 26 of this review homework. As a matter of fact, I'm going to actually write 26 and 27 down. Since they look similar, but I'm going to actually solve them differently. And usually my goal when I try and solve an equation is try to figure out the easiest method to solve it. So here's 26. Log base 5 of x plus 6 equals log base 5 of 14. And basically, we're asked to solve this equation. Now let me write 27 down here, and let me talk about both of them as a way to help you understand how to solve these kinds of problems. 27 is another equation to solve. 2 times log base 2 of x minus 3 plus log base 2 of 2 equals 5. And once again, we're asked to solve this equation. So these are both equations with log terms. You notice 26, log term equals a log term. So 26 are just two log terms, opposite sides of the equal sign. And when I go to 27, I have a log term plus a log term equals a number. So actually 27 has 3 terms. 2 of them are log terms, and 1 is a number. I'm actually going to solve these problems differently. And here's the key. If you have a problem where all your terms are log terms, what I'm going to do is I'm just going to have, in this case, they're both log terms, and they're equal to each other. Hopefully common sense says, since they're both log base 5, common sense would say for these to be equal, then the inside of this side has to equal the inside of the other log. It's almost the same idea when we were solving those exponential equations. If you have 4x times 4 to the 2x minus 5, right? We just said, hey, since the bases are the same, obviously the exponents have to be equal. Well, here, log base 5 of both sides, obviously, the stuff inside the logs have to be equal. So for 26, I simply say x plus 6 equals 14. Wow. Really easy problem. Although, I need to say this, the thing you have to do whenever you're solving a log equation, there's one of those problems where you must check solutions. Meaning, once you get your solution, what you have to do is you have to take that x and you plug it back into the original equation. And the thing you're really looking for, you have to make sure you never end up with a negative number inside the log. That's usually the thing that's going to get you. There may be problems where you solve it and you do the math perfectly and you get 1 or 2 solutions. You take one of your solutions, you plug it back into the original equation, and next thing you know, you have a negative number inside the log. At that point, you stop and you say, I can't solve this. That's impossible. And then, therefore, that is not a solution. That will happen. So in our case, if you plug in 8 for x, You get 8 plus 6, log base 5 of 14 equals log base 5 of 14. It checks out. That is, in fact, your solution. So this thinking even applies. There will be some equations. The key is if you have all log terms. In other words, I could have something like this, log base 10 of x plus log base 10 of x, or log base 10 of like 2, just for fun, equals log base 10 of 8. Here I have 3 terms, but they're all log terms. If I have an equation with all log terms, what I'm going to do is I'm going to go to each side, combine each side so I have one log term on each side, and then I can set the insides equal. So here, let's go ahead and combine these 2 log terms into one term. All right, I have the same base, no coefficients. Log x plus log of 2, I can combine it to log of 2x. So now what do I have? A log term equals a log term, I know. Therefore, the stuff inside must be equal. X equals 4. I put the 4 in here, everything's okay. That's a solution. All right, so that's the first kind of equation you're going to see, where all the terms are log terms. However, now, let me write 27. 27 also has 3 terms. 2 of them are log terms, and 1's a number. In this kind of situation, if you have log terms and a number term, what I'm going to do is I'm going to get all the log terms on one side, get the number on the other side. Okay, I already have that. And then I'm going to combine all the log terms into one log and then solve it from there. And we'll talk about that as we go. So first of all, I notice I have 2 log terms and a number, so I'm going to get all the log terms on one side, which they already are, the number on the other side. Now I want to combine these 2 log terms into one log. So remember my rules. Same base, no coefficient. Problem is, I've got a coefficient here. So the first step is you move it inside. Now inside this log is x minus 3 in parentheses. That whole parentheses gets squared. Now I can combine these into one log term. Since they're added together, I'm going to take x minus 3 squared times 2 So now we're back to the problem we had a little while ago. We have a log term on one side equals a number. What did we say to do to solve this kind of a problem? You have a log term equals a number. So I'm going to solve it. I'm going to convert this log equation into an exponential equation. If you check your notes, we just did that like 4 or 5 problems ago. I do the circle method, right? 2 to the 5th equals everything inside the log. I'm going to put the 2 out front. 2 times All right, now I have to solve this equation. Let's divide both sides by 2. This ends up being 2 to the 4th, which is, I think, 16. Now, in looking at this, normally what you might have to do to solve is you might have to multiply out these parentheses, right? You may have to FOIL. And I could do that, but I see a little shortcut just to save time. Because then what I realized, how about if I take the square root of both sides, I would get plus or minus 4 equals x minus 3. So x equals 3 plus or minus 4 can be two solutions, 7 and negative 1. Now please, let me say it again. Whenever you solve a log equation, once you find your solutions, you're not done. You have to check each solution. You have to take each solution and plug it back into the original equation. And in this case, you have to make sure, the main thing is you have to make sure there's no negative logs. So if I take the 7, and I plug it in here, 7 minus 3 is 4, that's okay. And that's the only variable. So the 7's okay. Now, if x is negative 1, I have negative 1 minus 3, which is negative 4. I'm trying to take the log base 2 of negative 4. I cannot do that. I can't take the log of a negative number. Therefore, even though I did the math correctly, that cannot be a solution. As it turns out, there's only going to be one solution, and that is x equals 7. So let me summarize this again. Log equations. 26, all the terms are log terms. Right? And in this case, a log term equals a log term. You can just set the stuff inside the logs equal to each other. 27, 2 log terms and a number. So you got to make sure the log terms are on the same side, the number on the other side. Combine the log terms, which we did here. And then you end up with a log term equals a number. Convert the log term into an exponential equation, and then you can solve it. All right, hopefully you've got that down. Looks like the next couple problems are some exponentials, so let's stop here and we'll start with another video, problem number 28.